This is DigitalOcean. This is one of the cloud environments that we use. Reason I'm showing this to you is hopefully you guys also learn a little bit of the cloud. Wherever you want to go in your career, if you don't know cloud, I can assure you in 2-3 years you will not have a job unless you know cloud, right? So at least the fundamentals of the cloud. And we have DigitalOcean available to MemSQL team. I myself run a MemSQL cluster on DigitalOcean. So if I go to this is my personal project, and this is my MemSQL cluster here. So I have a sandbox created here for some interviews that we do. I'm going to use one of these droplets for this call. That's why I'm showing it to you. And if you're in DigitalOcean, you can always click on create, and you can create droplets or Kubernetes clusters, obviously databases, but their database is Postgre and MySQL, which we don't care about. But there's a lot of things here, from load balancers to firewalls, DNS, droplets. So if you really want to simulate a client, you can do that on DigitalOcean. Let me see if I have a droplet here that's using Red Hat Linux or CentOS instead of maybe it's this MemSQL itself, because I would like to, yeah, this is using CentOS. So let me log into this one, and then we'll take it from here. So if I go in TechMonks, whenever we create a droplet, we put the password in the tags, so I know how to log into it later. So the cloud team, if you don't do this, will come after you at some point or the other, because they go through an audit every month to figure out which droplets should be deleted, so our bills don't get too high. And that this is one of the ways we track it. So this one's telling me I can log into this with TechMonks as my user ID, and the password is DLT for TechMonks. So I'm just going to use that. And I'm going to use this IPv4, which is 198. This is my public IP. This one is turned on right now. So if I want to log in, first thing is terminal is your friend. If you are working on Linux, at least from a client environment perspective, this is the only thing you'll be using is terminal. I am on Mac, so I'm going to use this. On Windows, you will be using PuTTY, P-U-T-T-Y. Both of them at the end of the day will give you the same experience, so I'm just going to use Mac. Second thing is we use SSH. If you use PuTTY, that's the protocol you have to use always to connect to Linux. So I will say SSH, and I think the account is TechMonks. I'll say TechMonks. This is the user ID at the IP address, which I copied. So this is the SSH command. If you are on a Linux terminal and you want to log into another Linux box, or if you are on a Unix-like operating system, which Mac is, then you can use this command. On Windows, PuTTY would have a user interface where it gives you a place to put in the ID and the host name or the host IP. So this is essentially saying I want to log into this box with this user ID. I press enter. It will ask me about the host key, which is essentially used it's a very old idea. It says if I'm logging into the right box or some other box simulating me or whatever, but it's not really useful most of the times. So anyway, it's going to ask me for the password. I know the password because I just looked it up from the cloud, so I'm going to log in. So now we are logged in to a Linux box. To clear the screen, the command is clear. I use this a lot because I like to keep my screen clear. One of the first things you guys may want to do is look at files, etc., especially if you're looking at MemSQL. So for example, there is this history command because I was using MemSQL, so this contains my command history. When you do ls, ls is the command. It stands for listing. So it gives me the directory listing. Shows a few important things right away. Number one is on Linux, every file is owned by a user and a group. So this way you're seeing TechMonks essentially means the user is TechMonks and the group is also TechMonks. This can be different. By default, every time we create a home account in Linux, it creates a group. At least CentOS and Ubuntu does the same thing. With the same user ID, it creates a group as well, and all the files by default would be owned by that user and his group. Second thing you want to pay a lot of attention to is this thing. This is called the permissions. So what does it mean is D means it's a directory, right? So this one is a directory. This one is also a directory. So dot means current directory, dot dot means my parent directory. Then there will be three fields, um, three fields, like that. Sorry, four fields. So that would be read, write, execute. That's what this RWX means. And same thing, read, write, execute, read, write, execute. The first one is, so it stands for UGO, user, group, and all others, okay? So when I say read, write, execute here, it means that the user can read and write and execute the files here. So this is my current directory. I'm the user TechMonks. R means I can read anything in this directory, so I can do this directory listing. Write means I can create files in this directory. And execute is required to actually change into directories. If your directory does not have an X permission, you cannot change into it. And also, if you're going to run any files, they need to have an execute permission. So this means that the user, in this case TechMonks, can read, write, and execute. Or let me pick a file like this, let's say. Okay, so this one I can read and write, okay, as a user. As my group, I cannot execute this file. So if I try to execute this file, I will see an error. My group, which is TechMonks, also can only read, cannot write. So if I added some other user who's on this operating system into my group, that user would then be able to read the file, but he would not be able to write to it or execute it. This is a good way for me to give permissions to people to, read my files, but I don't want to give them permissions to actually write to it, right? Same thing, this is for all others. So this says all others can read this file but cannot write or execute this file. So if I look at the permissions, they are also intersection of each other, which means if there is some permission that's not given in my directory, usually those users would not be able to do that. So for example, my directory listing is read, write, execute for me and my group, but not for all others. So if somebody else wanted to see if my directory had this file, they would not be able to see it because I don't have a read permission to it. But if I gave them a path to this file, they would be able to read it because this file contains a read flag for all others, which means they cannot know this file is there, but if I gave them the path, they would be able to read it inside my directory because the file has the read permissions. But most of the cases, you want these things to match. So if you really were expecting people to come inside your directory and read your files, they should have been an R over here as well. I didn't create these files, but that's how they got created. Again, this is not really the permission we would want to give, because usually this last three should be all empty like this. You really don't want to give permissions to everybody else on the system to read, write, or execute any of your files. If you really want them to look at it, there should be a good reason for it, doing it on the OS itself. Any questions so far on permissions?
No, this is fine.
Okay. So now we can change permissions by doing a chmod. So I can do chmod and I can say, let's pick this file, MySQL history. Let's say I want to give read, write access to this file to everybody in my group also. So I will say G plus RW, which what that means is my group should be able to read and write to this file. And then you type in the file name. When I do that, if I do a ls-al again, you see it has a RW for my group now. So what I said was chmod, give my group permission to read and write. So in chmod command, you can do UGOA. So that stands for user, group, owners, and all others. And then you can say what permissions you want to give them. So read, write, execute. The worst one is obviously this, because I'm saying do everything to my files. If I did this, then my file would essentially become universally readable, writable, and executable by everybody. So you see, it becomes a read, write, execute, read, write, execute, read, write, execute. So if I clear my screen and show it again, sorry, you will see, and it turns into a different color because I turned it executable as well. So when file is executable on send, typically by default, you will see it in this kind of a green kind of a color. It also depends on what terminal emulator you're using, PuTTY may or may not show you the colors. I'm not fully sure. This way we can, control the permissions. There is another way to control permissions, which is using a number. So if I did, for example, 644, and I said this, and I did a ls minus al, you'll see it becomes read, write, read, read. 644, the way it works is that 4 is here, 2 is here, and 1 is here. What that means is, for the first group of these permissions, I'm saying make it 6, which is basically 4 plus 2. So it becomes read, write. If I wanted to make it executable, I would have to add 1 to it, because this is 1. So 1, 2, and 4. So if I made it 744, for example, it would become read, write, execute, read, and read. So this is a short form of using what I was showing before, which is this one. I prefer this one because it's very clear what I'm trying to do. Unless you become really good at this stuff and you start using numbers all the time, I would suggest you use the long form, because it makes it extremely clear what permissions you are setting on your file. When it will become useful to you is when you log into a database box and you want to type a log file or something, and you don't have permissions to do that. And if you have sudo permissions, theoretically you could change permissions or look at what's going on. Similarly, let's say I set my database to write to a certain directory, and the user ID of the database does not have the permissions to write to that directory. Then your database will not be able to work, and you'll see errors. I think we saw this somewhere in EOG before, where they were setting it to write to a directory, and you didn't have permissions to write to it. So if you get a ticket like that, where the error is I cannot write, this could be one of the reasons, not the only reason, but this could be one of the reasons that permissions are wrong. So what I would suggest is, you look into this command called chmod to get more help on it. Now on Linux, anytime you want to look up something, obviously you can Google, but on Linux you also have this command man. Man stands for manual. So if I say man chmod, you will see a complete manual on this command that will tell you everything you need to know on how the command works, and what you can do about it, and what are the different ways to the UGOA stuff that I was telling you. It will give you basically everything that I just told you, right? So this is a quick way to look up information on any command on the box itself, instead of having to Google it. Sometimes you may not have internet permissions, etc. You should be able to do a man on that box on any command. So for example, I use the ls command. If I do man ls, you will see all the different options that this command supports, and what you can do about it. So that's the permissions command, and that's the looking at directory command. So if you look at it, these are the 2-3 things we look at. The other thing is the file size, which is here. This obviously for database matters a lot, because we want to say, if somebody asks you what is the file size of this on the Linux box, is it too big, too small, then you'll have to do this command and get the size of the file. You can do ls minus al, but this is in bytes, and I'll have to mentally divide it or whatever to get it into kilobytes, etc. But I can do a ls minus al h. H stands for human readable. So if I do this, then you say it will put it in a format that makes more sense. It's 16 kilobytes over here. It would say megabytes for M for megabytes, gigabytes, etc. So you can do a ls minus al, or you can do a ls minus al h to get it in a more human readable format. So this is your file size, and this, I believe, is the date of creation, not modification. I'll have to look that up. But no, it is modification. Sorry, because if I touch this file right now, the date will change. So if I set touch MySQL history, let's see if it changes. Yeah, it changes. So this is the last time this file was modified. So again, this is quite useful for you. As DB guys, you're looking at a log file. Maybe the first thing you should look at is the log file I'm looking at the right log file or not? Because if the date on the file is not matching, today's date, that means the database is not writing to that file. Otherwise, this date would be matching today's date. Touch command essentially modifies the date or touches the file in a way. So we use this command either to create a 0-byte file. If you touch a file that does not exist, so for example, if I say touch ERT and I don't have any such file in my directory right now, if I do ls-al, it will show me that this file now exists and it's 0 bytes, right? So touch command will modify a file or create the file as a 0-byte file. The other command is rm. Be very careful with this command. It deletes files and you cannot recover them. There is no recycle bin or a trash box with this command. Okay, so if I delete a file using rm command, that file is gone. You cannot recover it. rm stands for remove. There is this version of rm, and then there is another version of rm which I really hope you don't learn, which is rf, forces to remove the file. rm has some safety features built into it. If you're trying to delete a very important file, it might it might ask you for reconfirming. So if you do a -rf, it will delete it without asking you anything, and that's one of the most dangerous commands on Linux, and I would suggest you don't use it. For example, if I try to delete a directory like this one, .config, it says I cannot remove it as a directory, but if I did rm-rf, it would actually remove it. So never really use that command, especially if you're not really good at Linux. I myself have many times deleted things that I never wanted to delete because I got into the habit of doing rm-rf, and that's a very dangerous habit. So just remember, rm is remove, and really you don't need to learn the more dangerous versions of this command. On a Linux box, there are a few other things that that are fundamentally going to help you. One thing is, let's say you are working on a problem, and you do a shift change, and you want to know what did the other guys do on this box. One way is you talk to them, and I would encourage you to do that. Another thing is I can just do a bash history. By default, Linux will log everything that you guys do. So if I do a history, I will get this history, and I can also see the date the commands were issued. The reason I'm telling you this is the client can always see what you're doing on the box. Every command that you type on Linux is recorded, and actually I can pull in the date also. So you cannot fool anybody on Linux to say I was working on this box. This is one of my favorite commands, because if somebody tells me they were working on this box, I run a history and I see they weren't doing anything, then I know they weren't working, right? This file .bash history captures everything. So if I do a cat.bash history, I will see the same stuff of what commands were being executed, etc. This also gives me completion history. So if I press the up button, my history file is read, and the console shows me the old commands. So the reason I said the history command is to tell you that you can also come in and look at the history and see what commands was somebody executing before you, and how they were executing and things like that. So there's a lot of if I do a man history, there is a lot of options. I don't remember the option right now, but it can also tell me what time you issued which command. So I can see if you're working on a ticket. If I really want to see what work you were doing, it would be, I can just look at this file. Similarly, for your command processor, at least for memsql and also MySQL, same thing can be done using this file, MySQL history. This is a hidden file in your directory, and it actually contains all the database commands that I have issued for a certain interval. So again, if you want, if I go into a box and you guys tell me you're working on a ticket and I want to know what work you're doing, theoretically I don't need to ask you. I can just type bash history and I can type MySQL history. I can figure out who's doing what and what has been done, and the client can do the same thing. So when you are on these shifts, don't think that there is no way for anybody to know what you're doing. Very, very easily the client can find out if you did anything or did not do anything. And this is one of the things that has happened in the past, because we had the client come back to us and said somebody issued a command that they should not have issued. So everything you do on a Linux box is 100% captured, and most probably is audited. And you really cannot, when you're on Linux, hide what you're doing. It should not anyway, but I'm just letting you know. The OS automatically records these things. Anything starting with a dot is hidden by default. So if I do a ls, it shows me nothing. I have to do ls minus al to see the hidden files. This is a convention on Linux and most Unix operating systems. Anything starting with a dot is hidden, and that's why you may not know that there is a MySQL history or a bash history file here. Mostly because they are hidden by default, and the data is captured inside these files. That's some of the fundamentals of files. To create a directory, it's same as Windows. You do mkdir, name of the directory. Remove a directory, rmdir, the name of the directory. If I create a directory and I copy or create a file inside it, let's say like this, and then I do a rmdir, it will refuse to delete it. It will say because it's not empty. Again, the operating system is telling you are trying to erase data that you cannot get back because you are trying to delete a directory that's not empty. Normally, what you would then immediately do is go inside that directory and see what's in it, remove it, right? Get out of it, and then do a rmdir name of the directory. This way, you can get rid of it. To rename a file, the command is mv. So in Windows, I think there is a ren command, but on Linux, mv is the command. It will do renaming as well as moving. mv stands for move. So to show you, let's create a file called my file. So we create this file called my file. I want to rename it. I can say move my file to my renamed file, right? So this command will then rename the file for you. You can also then move it between the directories using the same command. So if I do ERT, I want to move this file inside that directory, I will say move to inside the ERT directory. The file will then go inside that directory. That's to rename a file. The other thing that you can do on Linux, it's on Windows also you can do it, but it's not really used as much, is make a link to a file. So for example, let's say there is a massive log file sitting in one of the big log directories on the box, and I want to bring it into my folder to look at that file. I can just link it instead of copying over like a 10 gig file or whatever. So let me show you. If I create a directory here called temp, that's, let's say, my working directory, and I want to look at one of the log files. I don't know if I have the permission to, but let's try and see one of them. So where/log/messages contains the OS messages. So I want to look at this one. Let me make sure first that I have the permissions. Yeah, so I don't have the permission. Let me see if I have permission for anything here. Okay, so there is this one, dnf.log, that I can read because it has a R flag for me. So let's just say I wanted to read this file at my own leisure. So I can do something like ln -s, and this will create a symbolic link. The symbolic link would essentially be the file that I'm linking. So let's say this one, and dot to my current directory. Okay. So now this file exists in this directory, and it's a symbolic link to the other file. What that really means is, if you look at the size of it, it's not taking too much size because it's not a real file. It's linked to this file. So if I want to read it or do some things to it, I don't have to keep on typing this long path. I can just do this more DNF, and it will show me, what's in the file. By the way, the more command is a useful command to have, because it lets you look at a file one page at a time, so you can go through it quickly enough. So the ln command is essentially for creating symbolic links. The format is ln path to the file that you're trying to symbolically link, in which in this case is this, and then path where you want to link it. So if I want a second copy, let's say, and if I said this, then sorry, and it has to be -s because it's a soft link. Hard link is something that is not what we create most of the times. So now I have the second .dnf pointing to the exact same file, and the link has been created. If you ever see or want to see if something is a symbolic link, if you do a ls-al, it will show you an arrow for symbolic links. It does not show you this arrow for regular files, and then it will show you which file is linked into this directory. So essentially, this 2.dnf and the dnf.log both are showing me 16 bytes in their size, and are not really real files. These are just pointing to this file. If you want to remove a symbolic link, you can just remove it like this. Removing a symbolic link does not delete the original file; it removes your link. So it's safe in that way. This is how you can create symbolic links on Linux. Most of the times you would do this if you, for one reason or the other, wanted the same file and also did not care about if this file is getting modified, then you have a historical copy or not. So because when I do a symbolic link, I am just pointing to this file. If somebody modifies this file, the same modifications will show up locally for me because I don't really have the file, I just have a link to it. If you really wanted the file and not the link to it, then obviously you'd have to copy it instead of creating a link. Now, which brings me to the copy command, which is cp. So cp.
Rohit, sorry to interrupt, Rohit.
Yep.
Can I have a question here?
Yeah.
Yeah. So let's say if we delete this dnf.log file and then recreate it after some time, so will my link will be valid or it will be invalidated? This is Gaurav here.
Yeah, Gaurav. So your symbolic link, when you delete it, will be a broken link. And if you create it back in, it will actually start linking again. That's why it's a -s, a soft link, which means that it will survive those kind of things. So I can do it right now. So just why don't we do it right now, right? So let's do a touch A, okay? ln -s, okay? The file that I want to create a link from to the file. So now I got a file here called B, which is pointing to A. Let's remove A. And B now shows you in red. And you see A is flashing. It means it's a broken link, right? The operating system is telling me this link is broken. Let me touch A again. And look at it, everything is restored back, right? So this is exactly what will happen. If somebody deletes the file while the file does not exist, you will see it like this. And if it comes back, then things will go back to normal.
Okay, thank you, Rohit.
Yep. Clean my directory out. Okay, so now copy command is cp, and it's very simple. Copy from and where. So cp, for example, if I want to copy my MySQL history to current directory, this is the command. So this is copy from, dot is always means parent. So the one directory above this is my home directory. Copy my MySQL history file, bring it here. Now I copied it, obviously, so I didn't create any link. So this is a pure copy of that file, right? Other thing is let's copy that DNF file. Let's bring it here. Verilog DNF. What was it? DNF.log. Okay, to dot, and the operating system will say, well, where do you want to copy it to? So I want to bring it to this directory. So this is how you copy things. So now I've shown you how to copy, create, touch, delete, and create symbolic links. And these are basic directory operations. I also showed you rmdir, mkdir, and I showed you the move command, which will move things. So you can basically do all operations at this point compared to files. Now comes file processing, and frankly, how effective you are as a system admin or a database admin depends on two things. Number one is how much of you know which queries to run and which tables in the database contain the information that you're looking for. Number two is, do you actually know Linux commands to be able to investigate files? And both of these are quite important. If you let's say I'm a DB admin and yeah, okay, I run this SQL query, I can get this information. That's good. But a real good Linux admin who does not know anything about your database but knows everything about Linux can still find almost all the information you can find, just because Linux is very, very good at searching and things like that. So let me just show you. Let's say the file I'm dealing with is dnf.log. DNF is, by the way, the program to install packages on Linux. So if I really just want to see this file one at a time, I'll do this, right? And you will always see a timestamp most of the times, and what is happening. And if you see this timestamp, this is in UTC format, because that's why the T and Z are coming, and you can Google that, what that means. But for example, if I quickly want to see it, I can say more. More starts from the top. So the when I created this MySQL cluster, or sorry, MemSQL cluster, was probably on somewhere around this date, 13th of January. If I press spacebar, it will keep on going down, 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 and give me more of information. If I press Q, it will quit. So there are a few things we can do. This is a big file. I can run a command called head dnf.log. This shows me from the top of the file what is happening. Similarly, there is another command called tail dnf.log. This shows me from the bottom of the file what is happening. And let's say I am looking for information. Obviously, most of the times you're looking at tail, not head, right? Because the log file that is there, the database is adding more and more log entries to it. If I quickly wanted to see, okay, what happened today, and I just took a guess, I'll say tail minus n100 dnf.log. This will show me the last 100 lines from this file, because minus n100 means show me last 100 lines from the bottom of this file. So I can quickly see, what is happening in this file in the last day or so, right? Assuming that, I'm guessing whatever I'm looking for is going to be there in the last 100 or so entries. Typically, my watermark is 1,000. So I will say, okay, show me the last 1,000 entries. In Linux, the other thing is called piping. We can send the output of one command as an input to another command. So I can say pipe it to more. Remember, I was showing you the more command before. So what more command does is whatever you give it, if you give it name of a file, it will start showing you that page by page. If I send the output of this command to more is going to do the same thing. It'll say, okay, you gave me all this data, I'm going to show you page by page. So if I say tail minus n100 dnf.log pipe it to more, what that means is I'm going to look at last 1,000 entries in this file, one page at a time. And you see at the bottom here, it's saying more. So now it started showing me the last 1,000 entries. And I can quickly press my space bar and see if I see anything here that shows me that there is an error. So I'm seeing debug and I'm seeing info, but I'm not really seeing any error. And I can quickly eye this, like, I can just move my eyes through it. And I can see, okay, is this good or not? Now, why this is helpful is if you're a DBA and you know which log files you're looking into, and that log file is 1 gig in size, what are you going to do? You cannot do anything with a 1 gig size file. But if you do the tail command, even if it's 1 gig or 10 gigs in size, you can see what happened in this file in the last day or couple of days. Now, this is one easy way. There is another way or something else that I can do. I can say this, and I can say, well, I'm looking for anything that starts with error, okay? So grep is the most powerful command you will ever learn in your life. And if you can master this command, most of the times you're going to be like a ninja in finding issues and fixing issues. I don't care what it is, because grep can go through binary files, anything, and give you what you're looking for. So let's say I really wanted to know, is there any error on my box, in the last day or so? And I assume that I knew that like last 1,000 entries are probably for the last day. Then I say grep error. And if I get no output, that means it didn't find any such thing. Grep also, and I would strongly suggest you go and Google it and learn all the options. If I said grep minus I, that means case insensitive, which means if it was error that I'm looking for, or if it was error, it doesn't matter. It will be case insensitive. Again, there is no error. So let me say, okay, well, what about info? Is there any info? So you can see, and grep will actually highlight it for you to say, okay, I found these commands and they have info. Now you can see info is all capitals, but in my command, because I said minus I info, it showed me anyway. But if I take out this, then it's only showing me this other part, not showing me the ones over here with info. That's because it's case sensitive by default. So if I say, I need to find something, most of the times I say -I, because I don't know most of the times what is the case that I'm looking for. In which case it will give me, regardless of the how the thing is documented in the file, it will give me that information. So this, if I do this, then okay, so this is all the stuff that it's telling me. And the other thing I would do in a log file like this, let's say I did my -n1000, but I noticed, hey, this says 2021 0210, which is February 10th, and it's ending at 0212. But I really just want everything for 12th, because I don't care. My issue started from 12th. You can, grep is such a useful command. You can say grep this, grep it again, and grep this. Now you see it filtered it. These entries are only from 12th of February. So this is if I didn't know if it's 1,000 or 10,000, I can put a big number here. It wouldn't really matter, because using grep I can filter. So grep is your command to filter anything that you want to filter, and once you know, and you can filter it even more after that. So you can keep on adding more greps here to get into the depth of the issue that you're looking for, and grep will keep on filtering that for you. Any questions so far?
Yeah, Rohit.
Okay, I think
Sorry,
there was
somebody else had a question.
somebody else.
I think
Yes,
Shweta
please.
was saying something.
After you,
Is there a
Shweta.
way to search like after a keyword? I want
So
all the logs after a word.
yes, so grep also supports -n and -f. If I said -n10, this will actually start showing you all the log entries after that keyword. So -n10 means next 10 entries after when you find it, and it will show you that. And it also supports -b for before. So let me try and do this. Let's look at this DNF, and let's say I'm looking for something.
Logging initialized. I want all entries after the logging initialized.
All entries after it initialized.
Yes.
So
For
give
the
me,
last logging initialized.
you mean when the file started?
After a recent logging initialized. No, I want all the logs after that.
So do you know what is the first command, for example, when the logging initializes? Let's pick something like this. Like this is, let's say, my keyword, okay? Sub debug, right?
Yeah.
And let's say I'm looking for bunch of entries after this, because after this there is an error, okay? And I don't know if my file has this or not. So first thing I will do is I will say cat my file, and I don't really care about -n or whatever. So dnf.log, pipe it to grep -I and sub debug. So yes, I know there are some issues here. So then I'll say, okay, well, this does not give me enough information. What exactly happened, right? I want to know that. And let's say this is the date I'm interested in, not these other dates. So what I can do is, this is the date I'm interested in. Obviously, at some point, I will also have to grab this date, right? So if I do that, obviously this is going to reduce it even more. It just gives me 1. But now I say, okay, fine. The debug event that happened on this date, this is my keyword. This is my date. But what I'm also looking for is, and maybe -n, 10. So give me 10 lines. Let's first look at it, what it gives, and then we'll see if we can filter it down more. So now every time it sees this thing, it's giving me 10 extra lines after that. So I can say, okay, when this happened and what happened after that is right here. So this usually will give me what I need to know, on that particular keyword. I can also do a -b, which means before this happened, show me so many lines before it happened. Does that tend to answer your question?
Yeah. And
I
then
know what you're asking is, from there I want to see all of the file. There are other commands for that, like cut, where I can cut my file. But right now, I'm just saying, if you can put a high enough number for now and quickly get the information. Because what I use grep for is to really just find quickly if there is something. So I can say, give me 1,000, because I don't know how big this file is. But every time it has this keyword, it will start from that keyword, and the next 1,000 lines after that keyword, it will try to print it for me, and then I can try and figure out more from there. So these are some of the things that we can do, and depending on how I want to define it, I can refine it more. So for example, if I want a certain date, I can do that, and things like that. Now there is one more very big use of grep beyond this, because if you look at these commands that I was showing you, I knew which file had the information that I'm looking for. Okay. Sometimes I don't even know if the file has the information. Now this is, let's say I want to become root, just so that I can type every file I want. So let me become root. And by the way, the sudo command, it's not sudo root, sudo bash. Sudo will basically start anything you say as root. And most of the people, and I would say 95% of people fall in this category, they think if they don't give you the root password, but they give you access to the sudo command, you cannot become root. And that's a complete nonsense, because any command you run with sudo will be run as root. So if I said sudo bash, I will actually get a root shell. So if you give somebody a sudo access, they are root on your box for all intents and purposes. It's stupid to think if you don't give me your root password, but you made my account able to do sudo, I cannot become root. Because there is this hidden command, bash starts a new shell. So if I say sudo bash, it says start this new shell as root, and I become root. I can in fact change the root password now if I want. If I did this command, I can change my root password. So be careful about security on Linux. Anybody who can do sudo, unless you put more controls around it on what command they can put sudo on, for all intents and purposes, 100% they are root, and you get no extra security by not giving them the root password. They can always become a full root on your box. And the reason I'm telling you this is if you are in a client box, if you really need to become root, you can, but I would strongly suggest you don't. In case the client has not given you the root password, you can ask them for permission and say, hey, do I have your permission to become root for next 5 minutes, because I need to fix certain things on this box. If they say yes, then if you have sudo access, then you can always become root. So anyway, I'm root now, so let me go to where/log. This is an important directory from an operating system perspective. Where/log contains all the important log files for the operating system. This is good for you to know, because most of the times things that are going wrong would be in some file here. This one is called the systems. In Windows, if you remember, there is a event log. This is similar to Windows event log on Linux. Theoretically, it should contain messages from pretty much everything on the operating system. Most applications don't follow it, but theoretically it should. So different applications, so you see memsql actually follows it. So memsql is putting its messages into this file, /where/log/messages, and they will, it's telling me when the memsql service is starting, and what are the different things that that memsql is doing. I can see if my memsql service is crashing, and then all of that stuff. So memsql studio access, etc. So again, if I wanted to filter this file for memsql, I could have done just a grep, grep on it. So I would have said cat messages, send it to grep, and I'm looking for anything for memsql, and when what's going on would show up here. But let's say I didn't know any of this stuff, right? I just want to know, in my entire Linux box, is there anything here regarding memsql that I should know about? There is a command in grep called grep-r, which means recursive, and dot, which means starting at this directory. And what are you looking for? Memsql. And where do I start? This will actually go through every file. starting from my current directory or whatever path I give to it, and it will search for this word called memsql. And if it finds it, it will print it out, and it will tell you which file that word is in and what date and things like that. So, for example, in my secure log, I have entries for memsql. So I can now know this file has some information about memsql. I should look at this file more. So if you didn't know where is this information, I want to search my entire box, etc. Like, is somebody hacking me? Is somebody, so somebody tried to log into my box with a failed password, invalid user PG. So somebody's thinking I got PostgreSQL on this box, right? And they are trying to attack this box by doing SSH2. And why are they doing it? Because the port for memsql is open on this box. So obviously I'm going to start seeing all kinds of database attacks, and that's what's happening. Basically, these are all hackers from Russia trying to attack my box. This is this is just one very important command to remember. It's very, very useful if you can master it. If you say grep -r will be recursive, whatever you're looking for and which path it should start looking into. So if I say dot here, it's going to look into my log directory and every other directory underneath it and every file underneath it and try to find the string memsql. And when it finds it, it will tell me the name of the file and also show me the line where it found the string. Again, those things like -n and -b that I was showing you before work. I can use those. For example, if I say, okay, fine, find me memsql, and I really want to know if there is anything with error in any of those files, then this will show me, anything that has memsql and error in that any file from this path, right? So obviously I'm looking at the OS right now, but if memsql was exceeding memory, disk space, all of those things will typically get logged in here somewhere. In my case, it's not doing any of this. The only thing I'm getting is essentially attacks, which is fine. It is what it is. But I can literally go through my entire box, and I can find. And this is why I was saying, if somebody does not know anything about your database, but he's very good at Linux, that person can probably find more information than you can find, because he can use something like this, and he can find every error, irrespective of the case, that's happening on memsql on his box within probably 5 minutes. And you would look really dumb in front of that person if you said, I'm a DB expert in memsql, but I cannot tell you what's wrong in 1 hour, while you can tell me in 5 minutes. So these kind of things are important to learn. Just if you go into a box and you don't know anything, you can still find everything on a Linux box by using this command. There is no equivalent of this command on Windows. They have a search box, but it's nowhere as powerful as what grep can do for you. And the recursive command is quite useful. This is one of the most powerful commands from a debugging perspective that you can know about. The other thing is operating system errors on a Linux box, because I'm running out of time. I only have 3-4 minutes left. If you want to find out if the system is running out of memory, disk, etc., there's lots of ways to do it, but one of the first things you should look at is dmessage. Dmessage will give you all the important kernel messages. So if something is going on with the box, that is running out of memory or things like that, typically dmessage will show it to you, and you will see it at the bottom usually. You won't. So there's two things. There is var/log/messages, which contains messages really from every application, or it should contain at least. Then dmessage is for the kernel messages. So if the kernel is running out of memory, etc., it will tell you. And most of the things kernel will print here. So for example, it's telling me how much graphics memory I have, and how much VRAM I have. So this is another thing. If your box is misbehaving, one good command to remember is dmessage. Usually, this is one of my starting points. If I think that there is something wrong with my box, I will start at dmessage, just to see if the kernel is telling me that it's running out of memory or something like that. It will show up here. The other commands, and I will show you, is free -h, for example, you can do. So this will tell you your memory. So I got almost 8 gigs of memory on this box. I am using 966 megabytes of memory. I have free 5 gigs. And then there's buffer cache, etc. And I'm not using swap. If you are a database administrator, if the operating system is starting using swap, heavily, and especially if it's running out of swap, then you have issues, because that means the memory is not enough, and the system has started using the disk space for memory, which is going to be extremely slow, especially for MemSQL. That will kill your queries. And this is a quick way to see if my box is running out of memory or not. -h, again, human readable format, so that it will put it in gigabytes and megabytes instead of putting it in bytes, which I may or may not understand. So this gives you a quick, rundown of memory. If you want to see more information, there is this command called top command that will show you things like who's using how much CPU. Now remember, this thing gives you percentage memory, which is not really that important. I prefer the free command to know who's using how much memory, because as a percentage of memory, if something is using 5% of 8 gigs, okay, fine, but I don't want to take out a calculator to do that. Again, you can see MemSQL is obviously at top of this. It tells me it's using 4% CPU right now, and it's using 5% of my memory. I'm okay, I don't care, but the CPU seems okay. I mean, there's a master node, and then there's a leaf node, because it's a one box cluster on this box. My CPU is around 10%. This is okay. It's not too bad, right? Up here, it gives you a full readout of the CPUs. It gives you a full readout of your memory as well. Over here, how much is free, how much is used. Most of the people on your team would be using this command quickly to see what's going on, and which process is using how much memory, etc. If, for example, my MemSQL was showing me using as 60% CPU, then we know we have an issue, because it's using too much CPU. So these commands are two commands you should remember: top command, TOP, and the free command, which tells you on the memory. Now what remains is disk. We want to know what's going on with our disk. There's a command called df. Df stands for disk free, and if you do a df -h, it will show you what's going on with your disks, right? So I can see that I have dev/VDA1, 160 gigabytes, used is 7 gigabytes, available is 153 gigabytes. Nothing here is showing me anything is bad. Now, you may ask me, okay, this is great, but how the hell do I know? I'm seeing all these file systems here. These are all file systems: tempfs, /dev/VDA1. And you may want to know, okay, well, is this my database disk, or is this my database disk? There is also a command called mount, and mount will tell you what is mounted where. Okay, so now again, this is too much information. So really, I want to know what is this thing, right? Where is this mounted? So I can use grep as it is to see this device is mounted on my root file system, and that's the one my MemSQL is on, because really on this box I only have a root. Now it's also showing me here that it's mounted on root file system, so I didn't have to do that. I think this is the new OSs have it. In the old days when I learned Linux, it would not give us the mount point. It would just give us the file system. So I guess you don't need to use the mount command. You can just look at here, and you can see if wherever your database files are is part of this path, then that's what you need to look at. And if you're running out of space, then that's an issue, and you need to talk on the client side for them to increase your database disk space. So the top command, mostly I use it for CPU. The free command tells you what's going on with memory, and the df -h command will give you all the information about file systems and how much disk is there on the box, how much is free, how much is not free. I'm going to stop here. Any questions so far?
Yes, Rohit. Just like we track the processes, can we do the same type of tracking with?
One last thing, since we talked about threads, is proc/CPU info will give you a lot of information. This is proc stands for process file system. It contains the same information that I was showing you through the top, etc. command. Linux will usually put all this information in files also. So over here, if I say proc.cpu info, things like what is my processor, what is my model of the processor, how many cores I have, etc., would show up under this file. So in this case, I have 4 processors because you see this is processor number 0, processor number 1, processor number 2, and processor number 3. So I have 4 cores on this box. So if I wanted to know how many cores I have, I would do the same thing. I would say processor, and then you see I have 4 cores on this box. There's a lot of information you can get from proc. Thread for sure is here too. You should read up on what the proc file system contains, because this will give you pretty much anything that's going on your box without knowing any commands. If you type these files, you can see everything that's going on in your box. You can get the memory statistics, memory info. This is raw info, but if you type these files, they will potentially give you more info than the commands themselves can give. And this gets continuously updated. So this one is, for example, telling me how much free memory I have, how much buffers I have, inactive. This is deep dive, and this is what really good system admins would know, because they would know how many huge pages I have. All of this can impact your database performance. Same thing for disk stats. So Manmeet, for example, in his monitoring, he looks at disk stats, and he looks at a bunch of these things, and he can predict if this box is going to slow down the database or not, because he looks here. Over here, there is one thing for threads as well. I'll just find the path, and I'll let you know which one contains all the information for threads. Okay, but you guys can, if you want, you can Google this proc file system, and what all information you can get from this proc file system. Kmessage, for example, is the kernel messages file, which is same as dmessage. So if you didn't want to remember all the commands, but you knew everything is in proc, theoretically you can get all the information from here as well. Any other questions? All right, guys, I recorded this call, so I'm gonna send the recording out afterwards. We can do more stuff.